Assalamu alaikum. Good morning, everyone. My name is Sassia. I am PhD student at University of Biskra. I would like to thank the organizer to provide me this opportunity to present my work, Amphis Energy Management for Grid Connected Hybrid System Wind PV Battery. Let's begin with the contents of this presentation. First, introduction, after that description of hybrid system, then power management strategy, results and discussions, finally conclusion. Now let's start with a short introduction. Energy management of multi-power source has already been studied recently. For example, control, robustness, stability, and optimization of hybrid source remains an essential area of research. The application of energy management strategy using Amphis for grid-connected hybrid system which generate reference powers for energy storage system and grid power, taking into account the power of the renewable sources and the load demand and the state of charge of battery. The training data for the Amphis has been obtained using a rule-based approach, and the proposed strategy has been validated through a case study presented. Figure 1 displays the five major parts of hybrid system. The PV and wind generators are considered as the main sources. The PV's DC-DC boost converter allows making an adaptation stage between the PV generator and DC bus, as well as wind generator connected to DC bus through an AC-DC rectifier. The energy storage system using lead-acid batteries is associated with a bidirectional DC-DC converter. Finally, a utility grid is connected to DC-AC bidirectional inverter to maintain the power flow between AC-DC side of the system and to supply electrical loads. Let's turn to the operating mode of energy management. There are proposed three possible operating modes. The first mode, normal operation mode, the PV and wind generator satisfy the load demand, and the state of charge is always limited between 25% and 95%. The second mode, maximal state of charge mode. When the state of charge greater than or equal 95% and the net power is positive, the energy management controller disconnects the battery and the surplus energy injected into the grid. The third mode, request of utility grid mode. In this mode, the state of charge less than 25% and the net power is negative. The grid procures the lack of power required for load. The novel Amphis technique is able to generate the rules and tune it efficiently. It has two outputs, the reference powers for battery and utility grid. The data set was split into two group sets, the training set and the testing data set. Both groups obtained it through another strategy based on rule-based, to verify the ability to generalize the model containing all data. On the other hand, the testing dataset is different from the training dataset. The final error is determined by the square root difference between the current output and the desired output. As can be seen in Figure 2, the proposed Amphis structure consists of four data inputs are defined: P renewable power, load power, state of charge, DC power, as well as two outputs, grid reference power and battery reference power. The Amphis membership function for inputs is illustrated in Figure 4. Let's turn to results and discussion. The proposed model has been implemented in MATLAB Simulink software in order to evaluate the effectiveness of the energy management controller. Figures 6 and 7 shows training process result of ENFI's battery reference power and grid reference power in various irradiation, wind speed, and during variation of load. According to these figures, it can be seen that the ENFIs are well trained where it is given perfectly the desired output. Validation between the predicted results and actual results for testing phase are presented in Figure 8 and 9. The testing results demonstrate that the ENFIS is suitable for the online power management and has the minimum root mean square error. At the end, conclusion. This presentation has discussed a novel energy management strategy for grid-connected hybrid system based on ENFIS approach. Simulation results demonstrate the effectiveness of the proposed energy management controller for the hybrid system under various scenarios of power generation and load profile. On the other hand, the energy management controller based on ENFIS able to predict the future power of hybrid system. In the end, thank you for listening and for following up.